All right. Do juniors in a stats class, or just juniors all around, take different care of their textbooks? Or do we want to say better care of their textbooks? Better? All right. Do juniors take better care of their textbooks? I'll change my question. Oops, only 2 O's. Okay, so first let's look at our little sample. Well, let's look at the two populations. Let's define our proportion sub j would be the proportion of juniors here at our high school.
Around the world. Yeah. Actually, the whole universe.
The whole universe? Okay. Proportion of juniors in the entire universe. High school juniors, though. Yeah. Who have... We're going to non-humans now? Who have good condition textbooks. Obviously, even though this is the whole universe, we're just talking about public school textbooks. Don't you think?
I think it's fair.
Okay. And my P sub S will be the proportion of seniors who have good condition textbooks.
Does this say proportion of people should?
Proportion of seniors. Sorry, that was a lousy looking S, wasn't it? I don't know how you get emotion there, but okay. Let me state my null and alternative hypotheses. So my null hypothesis is there's no difference between juniors and seniors. And what shall we do for my alternative hypothesis? Okay, so they need to be greater because they need to have a greater percent.
They need to be lower.
We need to get lower percentage.
Do juniors? No, I said good condition. I went for good condition. So now I want juniors greater than seniors.
Oh, that's true.
Okay.
No, but why?
You're going to get a negative p-value here, aren't you? Okay. All right. No. Yeah. So, whoops. It's just display driver stopped working for a minute and now has recovered. Atikmdag? Atikmdag. No, display driver Atikmdag stopped responding and has successfully recovered. Who is Atikmdag?
That's your display driver.
Okay, I didn't know my display driver had a name. With 3 consonants together, making it hard to pronounce. Okay, now, when we do significance tests for proportions, we pool. Yeah, we always pool.
For significance tests, but not for confidence.
Not for confidence intervals, just for significance tests. Let me explain to you why. Your calculator always will pool these. There'll never be a question.
Is there a reason why?
Yes, I'll explain that after I write this. Okay, the reason that we always do this is because my null hypothesis says that the two proportions, the population proportions, are equal. if the two populations are population proportions are equal, and they're also, you know, infinitely large, as they are because we're talking about the whole universe here, then do you remember how we figure out the standard deviation for the sampling distribution of a proportion? P times 1 minus P, divided by sample size. So take the square root of that, I get the standard deviation. Don't take the square root of that, I get the variance. I pool if variances are equal. Well, my null hypothesis is that the proportions are equal. If the proportions are equal, the p's and the 1 minus p's are equal. Hence, the variances are equal. Okay? So we always pool for proportions. But, you know, nobody's ever, you know, you don't have to answer that question on any, on your input for your calculator. It always pools. So I get a pooled, and your book calls it combined sample proportion, which is going to be the number of yeses. How many S's in yes? Y-E-S-E-S. Yeses, that's it? Number of yeses in first sample. Sorry. Plus number of yeses in your second sample divided by sample size 1 plus sample size 2. There's my pooled proportion. You don't have to calculate it, but yes, you have to calculate it, but you never have to say yes to pooled. It's always pooled in the significance test. Yes. Pool means putting the two samples together, and in doing that, I can decrease my standard deviation when I pool, and then in doing that, I get to reject the null hypothesis a little more often. We don't pool for confidence intervals because we don't have that assumption of equal proportions for the two populations. Okay, so let's run these numbers here. Let's just get these numbers. What is my sample proportion for the juniors of the 0.8? Okay, I'm not looking back there. And my sample proportion of good condition books for the seniors? 0.64. Now my pooled or combined sample proportion is going to be the yeses for the juniors. I'm writing and not looking. So that's 8 and 11. So 8 for the juniors plus 11 seniors out of how much? 27. 0.70? Okay, nice. We will have to use this when we go through and check conditions. Okay, so down to step 2, name my test. We're doing a significance test. 2 population proportions. What distribution we're using with proportions? And there was a question that came up at the reading last year, and I can't remember how it was asked. If somebody said Z distribution, did they get marked down for that? And I think they said they didn't get marked down for Z distribution because we all know what you're talking about. But it's not called a Z distribution. It's called a normal distribution. Your test statistic is a Z, but the distribution is called a normal distribution. And we're going to do 2 independent samples. Okay, so my conditions. Did we have a simple random sample of all juniors and seniors in the universe?
Yes.
It was as good as, I think. Yeah.
Obviously.
Obviously as good as.